Did you know that not all zirconia is the same? Zircad Prime Zirconia from Ivoclar is uniquely produced with GT technology, which allows two powders that normally sinter at different intervals to be combined into one material which sinters uniformly. The manufacturing process not only optimizes the translucent properties, but also creates a seamless progression of shade while maintaining optimal strength. Zircad Prime and Prime Aesthetic is now more affordable than ever and will give you the results that your dentist will notice. Contact us today to learn more about Zircad Prime and how Ivoclar can support your success. Tell them you heard it on the podcast and get a free Prime or Prime Aesthetic disc to try. Just use promo code 723. For all this information, visit the Ivoclar tab on the Voices from the Bench website. This is Laura Gilbert, Director of Technical Marketing at Ivoclar, wishing you a successful 2024.
Welcome to Voices from the Bench, a dental laboratory podcast. Send us an email at info@voicesfromthebench.com and follow us on Facebook and Instagram. Greetings and welcome to episode 302 of Voices from the Bench. My name is Elvis.
And my name is Barbara.
What's happening, Barb? How are you?
Good.
Yeah?
You gotta say Happy New Year still, because it's still in the first week, I think. Maybe going into the second.
We'll let it go. We're the second Monday of the new year. We'll still let you say New Year.
All right.
I woke up the other day to our first official accumulated snowfall here in Indiana.
Ooh, how was that?
As someone that was really looking forward to go for a run,
No.
not welcomed. Yeah,
So,
we had about 2 inches.
Is that a lot?
It's pretty common to get started. We'll probably see a couple more inches by the end of winter.
Well, fantastic.
Yeah, so that means I have to go run at our local gym,
No.
which is an indoor track.
Right? Oh, that's not bad. At least it's a track.
Yes, I can't do treadmills anymore. My brain cannot comprehend that. But going around the track 12 times equals a mile.
Oh, God.
I ran around that track 72 times.
Oh, no. I don't know if that's worse or better than a treadmill, Elvis. Oh.
A little dizzy when I was done.
All right, well, at least you did it, you know.
Yeah, that's true.
Put one in your corner for running around the track.
Hey, I still got out there
Yes.
and ran when most of the city and state didn't because of the snow. So there you go. So we were going to record Friday, but you couldn't. Something about filming at your lab? What are you guys making, a movie?
You know, people want to put things online, and, you know, I just think anything that you should do really well.
Yeah.
And so we just had, like, one of the guys that's running our sales brought his brother in, who actually does it for a living, and they set up, you know, they took pictures of cases and they filmed us individually talking about our individual laboratories and what we do and how it benefits our clients. It's more for doctors,
Sure.
you know, to kind of get to know me and the CAC group in the lab. And, you know, so it was fine. Took all day. It ran my nerves up a little bit because I'm like you. I like doing audio.
Yeah.
I don't think anybody's as comfortable unless you really like it in front of the camera. So, you know, it took me several takes to calm down and get my heart rate back to normal, but you know, it's done. Let's just put it that way.
So did you like get your hair did and did the whole makeup and thing? And
I fixed myself up before more than I normally do.
Did do the air hose shower to just get all the dust off?
Yeah, pretty much. But yeah, it's done. We'll see how it does.
Where can we see these? Will they be on your website?
Sure, you're going to see them on LinkedIn and like that. So yeah.
I will totally share those to our fans.
Yeah, you and Joe can make fun of me. I'm sure you will.
And we will.
I know. All right, so what's going on?
So yeah, now that we're well into January and the start of 2024, we finally get to say that LMT Lab Day Chicago is next month.
I know, and I've seen it all over the web. So yeah.
People are excited. I think since it's not an IDS year, it's going to be huge.
It's always huge, but yeah, I would agree.
Yeah, it gets bigger when IDS isn't going on because the companies have more money to spend in Chicago.
Bigger's better.
Yep. We will once again be in the large and fabulous Ivoclar Ballroom which is right across the hall from the registration desks.
I know. Cannot wait.
So for those that don't know, this is the biggest dental lab meeting of the year in the U.S. And if you can be there, you better be going.
That's right.
Because every year, thousands of amazing technicians head to the wintry cold of Chicago, and we check out the vendors, the seminars, the classes, the parties, the get-togethers, the food, the drinks, and we all talk things teeth. It's such an amazing time.
Yeah.
Cannot wait. February 22nd to the 24th, which is a Thursday to a Saturday. But Barb and I, we're going to be recording the second half of Friday and all day Saturday.
And I'm going to be on time.
Yeah, because Cal Lab's closer. You just have to walk underneath the ground in the hall.
I know.
Yeah.
So much more convenient.
So much more. We want everyone to come and say hi and hopefully sit down with us and be on the podcast. You know what I'd really like to see this year?
What?
I'd really like to catch up with some past guests that we've had on that just want to come on and for 20 minutes talk about the exciting things they've been doing since their episode aired.
And Elvis really likes the 20 minutes, so brace yourself. And I'm always the one going, there's a line, Elvis, there's a line.
Okay, if you can only give me 10, that's fine.
Right, that'll work. As long as there's 100 of you, then we have plenty of content.
Yeah. So just make sure you head over to lmtmag.com to register for Lab Day. It's free. And then come see us in the Ivoclar Ballroom.
And we will see you there.
So we have talked a lot about 3D printing on this podcast.
A few times.
Quite a bit. We talked to the people that use it, people that sell the printers, and even some of the people that make all the resins. But there's a whole new 3D printer in our industry that is just taking off.
Oh, yeah.
Metal printing.
It's crazy.
Yeah, that's cool.
Yeah.
This week, we got to talk to Josh Williams from GPS Dental Labs in Orlando. Actually, he's part of their GPS RPD division that only prints frames for other labs. We love the fact that we get introduced to metal printing on this podcast, not from the manufacturer of the printers, but from a technician who actually did frames the old analog way.
Oh, God, that's a pain in the ass.
Then to printing resin and casting, to this new and better way of just printing the metal.
Yay.
Josh talks about his journey in dental technology, how he opened up his own lab in a bait shop, to partnering up with GPS to bring them to this new level of technology. We learn all about the processes, their early struggles of getting it right, what it takes to run these machines, the post-processing it takes, and how they compare to the frames that we're used to. So join us as we chat with Josh Williams. Whether you're looking to elevate your craftsmanship or looking to cut back on cost, look no further.
VITA MFT teeth are the ultimate solution for creating lifelike and stunning smiles.
Crafted with precision and backed by cutting-edge technology, VITA MFT teeth offer unparalleled aesthetics and durability.
And since VITA believes in the power of experiencing excellence firsthand, for a limited time only, they are offering you the chance to get a complimentary case sample.
That's right, a full case absolutely free. Just visit vitanorthamerica.com/free MFT.
Don't wait any longer to start providing your customers a premium tooth at an economy price. Redeem your free case sample, and if you're ready to buy, VITA will even give you an extra 10% off discount by shopping online on their newly launched online store.
Join the VITA family today, and we appreciate your support of the podcast.
Hey, it's Candulor from Switzerland. Whether digital or analog, there are many ways to work in removable prosthetics, and you decide how you want to work at your bench. We provide you the materials to do so. With our new X molds of the PhysioSet TCR tooth line, you can cover a large part of your daily work. Whether complete dentures, partial dentures, or hybrid prosthetics, there is always a solution. Our Swiss School of Prosthetics in Springfield, Missouri will be happy to teach you a few more things you learn for life, right? You'll be supported and supplied by our authorized dealer, Edmunds Dental Supply. Check out our website, candulor.com. Candulor, high-end only.
Voices from the bench. The interview. We are super excited today to bring us somebody from Barb's home state, from an old friend of ours, GPS Dental. Josh Williamson joins us. How are you, sir?
Doing good.
Awesome. So, like I mentioned, GPS, we had Andrew on the podcast many years ago.
Yep.
And back in that interview, Andrew kind of dropped this bomb that he's like, I'm going to be getting into metal printing and doing partials. A couple years later, here we are, and you're running the whole thing, right?
I am.
That's fantastic. I see your posts on social media. You're printing I don't know what the correct term is for a buttload of metal. But you are printing a buttload of metal.
It's quite a few. We like to average about 60, and we just added to the fleet, so that'll be picking up after the first of the year.
That's fantastic.
So before we start nerding out on printing metal, which I'd love to learn more about, what about yourself? How did you get into this whole industry?
Well, actually, ages ago, about 16 years ago or so now, a friend of mine was working in a dental lab, and I was mowing grass, doing landscaping, and was cruising by him, and I said, you guys seem to be having more fun than I am. It was August and 100 degrees in Florida, so jumped in there and got thrown in the model room like everybody else, and kind of just grew it from there. It was the old top quality partials, if anybody still remembers those days. I did about 10 years there, and then they got bought out by National Dentex and fun corporate stuff and all of that.
Yeah.
We left the corporate world. I had a little bit of a no-compete, which is always super fun.
Mm-hmm.
Kind of started my own little business from there, kind of, waited for my 2-year no-compete, and then I actually opened my own little removables lab. We bought a bait shop and turned a bait store into a dental lab.
Come on.
How'd you get rid of the worm smell?
It never goes away. They had the live fish tanks and whatnot, so it was like the ultimate smell.
Both my sons are fishermen, just saying, so I totally get it. Can you guys hear my bells?
Unfortunately, yes.
Okay, that's on my neck. Sorry, it's Christmas.
Okay,
time.
just don't move, Barb, for the next hour.
All right.
So, for 10 years, you worked at a lab. Were you in the model room all 10 years?
No, I went through the entire stage of metal there. So I started in the models back when we were doing, casting refractory models and whatnot.
Sure.
So all of that fun stuff. And then I moved into metal finishing after that. Kind of rolled through there and did most of my time in that, as well as kind of bouncing around. I repair a lot of equipment. And
you were that guy in the lab, huh?
Oh, I'm the one that they always bring their problems to. It's it's fun.
Metal finishing is tough.
Yeah, you lose fingers in your fingers.
Oh, yeah.
You don't have fingerprints for a while, so it's real hard to get into, any biometric plays or anything like that. It's fun.
But easier to commit crimes.
I guess so, yeah, for sure.
You went through metal. Did you get into any digital back then?
Very little. When I left there, they had bought a bunch of the Bago printers and whatnot.
Oh my God, we had those. Yep.
Yeah, that went super well as everybody else's experience.
Yeah.
Uh-huh.
Early 3D printing.
It was a struggle, and they ended up actually throwing a lot of that stuff in the trash. So now, other than the printers, all like the pressure chambers and all of the equipment used for that, they threw in the garbage. So I ended up with a bunch of stuff at my house. So that was pretty cool.
Oh, did you go dumpster diving for it?
Didn't even have to. So the guys there, corporate, they've got a list of what's cheapest to do and what's not. And I guess it was cheaper to throw it away than it was to ship it. So
Sure.
I just pulled my truck up out back, and they actually just loaded it in there. I got a laser welder. They threw away a laser welder. So
You're kidding me.
it worked. I did laser welding at my house for, 2 years.
Wow.
So they allowed you to pretty much set up your own lab by throwing everything out?
I'm telling you, that's basically how I started my own lab, is because I was like, well, I have a shop full of dental equipment, and I don't really do much dental at the house, so why don't we go ahead and fill up this bait shop?
Wow.
So what'd you do for the 2 years that you had a non-compete?
So again, fixing equipment and whatnot, pretty handy. So I started a handyman business, actually. So I was just doing like basic home repairs and whatnot. So it was,
wow.
It was interesting.
That is fascinating.
See a lot of interesting stuff doing that, going to everybody's house.
So after you got out for 2 years, for some reason you still went back.
Yeah, I did a full year of just that, and then the second year we were setting up the lab. We already had plans. We already had to, put it in place and whatnot. Just couldn't put my name on anything. So we were setting that up and building that as that was going on. I actually doing home repairs ran into a guy, and I turned off a water hose, and he came running out, and he's like, "Hey, you turned off the water to my lab," and I'm like, "What are you talking about?" I walked over and looked. I was like, "How you doing dentures?"
You got to
Yeah.
be kidding me. What a small world.
In his backyard in a shed. And he's from Canada. Moved down here directly from Canada, started here. I was like, what are the chances? So it was really cool.
So when you opened up the lab in the bait shop, what kind of lab did you open?
It was just removables. It was mostly acrylic. We also did flexibles and whatnot, but yeah, mostly just acrylic work.
So how did you learn how to do removables?
Dabbling in the lab, I kind of knew how to do everything. Any downtime and whatnot, I've got the attention span of a gnat, so I can't sit still, and I would just bounce around. I can do enough to get by in just about every department now. So I kind of run through. I can run over there and do dye trimming. I can't do ceramics. That's the one thing I can't do. I'm terrible. But anything else kind of throughout the lab, I just kind of stuck my nose in and figured it out, and trial and error, got pretty good at a little bit of everything.
That's pretty ballsy.
So talk about growing your own lab. You hung a shingle, as they say, on a bait shop. And how'd you start getting work?
Just hitting the streets and going out there face to face and going to all the local dentists that kind of, I didn't have a giant reputation, but where we came from, at least they kind of knew me, and I, talked to a lot of these doctors. So we just kind of started slow and started off, one or two here or there, and eventually it got to the point where we were pretty busy. I think we had, like 8 doctors by the time that I left there. It was picking up. It was a good run there.
You
say we.
Say we. Hey, Elvis, that was my You say we. Who were you? Did you have a partner or a wife or what?
No, my wife is in the industry. She actually works at the lab here, but it was the guy that I ran into that had the lab in his backyard. His name was Paul. We started that and whatnot, and anybody that started their own lab knows that it's about twice as busy as working at a lab. So yeah. I had a daughter at the time. Once she was born, I had to kind of go back to working for someone because I couldn't put in 20-hour days anymore. Just tone it back to the 10-hour day usuals.
Sure.
Yeah.
So that was that. He's still up and running. I pass him. I stop by and talk to him all the time, and he's still trucking along right there.
He's still in the bait shop?
Still in the bait shop?
He's still in the bait shop. He's still got one of our guys that works here actually goes there after hours and works a second job there to help him out still.
So you helped him graduate to a bait shop from a shed in the backyard. That's pretty fascinating.
It was a step, I guess.
Yeah. It's a step in the right direction.
It's a smaller step, but it's a step.
Yeah. Now he's got a real building. He can leave and escape the wife and go to work and actually escape rather than just go in the backyard, because she would just come out and yell at us all the time. Are you guys done? Uh-oh.
So when you had your daughter, that's when you realized that the 20-hour days, it was time for you to go back and work 10. So that's when you went to work where you're at now?
No, actually, I went to Team Solutions from there, another lab here in Orlando. And I put in a few years there. I actually started there and they didn't have partials. They weren't doing partials. They were, just kind of getting it set up. And the owner of Team Solutions was my prior boss at Florida Laboratories at National Dentex when I went there, which that's who bought the first place. Top Quality Partials got bought out by the corporation and whatnot. So, it was a pretty easy walk in there. He was happy to see a face that he recognized and let me kind of just set it up. I set up the entire partials, and same thing. I was about 3 years there of the only partial tech, and that kind of ramped up to the point where, 10-hour days turned into 12-hour days, turned into 14-hour days. And then I was like, all right, I'm in the same situation I was before, so I gotta tone it back. So came over here to GPS.
What was the workflow that you set up there? What were you printing?
We weren't metal printing. We were print to cast. So we would resin print, the framework and then cast it. So we were still casting at the time. So it was still a lot of manual labor. And I was doing everything from design to, finishing and processing and everything, investing and casting. I was the guy. So it was a lot when it got up to about 20 frames a day.
Yeah.
So did you used to wax the frames?
Back in the Top Quality days, I dabbled in wax. I'm a little too impatient for wax. I can muscle through it and I can make a really ugly partial, but I am no good at wax. So I did everything but wax.
Well, I'm just kind of curious because I've heard a lot of people mention that printed wax frames compared to hand wax frames, the hand waxes are better.
Yeah. I heard that like 5 years ago, but I'm assuming they're getting better as the years go.
It was really about that finding the right resin that burned out clean and actually came out like you wanted it to.
Mm-hmm.
We didn't even use the resin that was even intended for this. It was more of a model resin. It's the one we kind of, burned out the cleanest and actually gave us
Really?
the best result. But they were a lot cleaner than anything that was done on a refractory. Those refractories are just notorious for porosity and holes and pits and bubbles and fun stuff. So it was a step in the right direction. It was definitely easier than doing the old, castings, but I wouldn't say it's anywhere near as clean as what we do now. Definitely an in between step.
Yeah, so you would design on 3-shape?
Yep. We would design on 3-shape and then just resin print that. You would still put the little, support. So whenever you would put it in the ring to invest it, you would get 2 or 3 in each one. So it was a little easier too. We're not investing, one ring per frame every time on a refractory model.
Yeah. And then you still had to polish it when you were done.
Oh, you still had all that fun stuff. That process was, identical. It's still actually very similar now, just a lot more clean. So there's a lot less bubbles and porosity and whatnot. You get a much cleaner frame to come out of there. Now you're just supports.
What's the difference?
So with a casting, you got that liquid metal that's trying to get through all your your little orifices and whatnot as you cast. A lot of time curved, it just does not like it. So you get a lot of short castings and a lot of bubbles and a lot of just hits and whatnot. It's just not the greatest process. As well as the metal, it's porous when you're shooting it through there, and it shrinks whenever you do that. There's a lot to the fit, greatly improved with printing for sure.
So you used to cast it, now you print the metal?
Yep, print straight out. Whenever the printer's done, you pull it out and you have a plate that's just full of finished frames.
What the hell kind of metal is that?
It's still chrome cobalt.
Wow.
Nope.
I did not know that.
You got to run it through a dealing, but that's it.
Andrew wanted to start doing this. Did he approach you or did you approach him?
So when I left Team Solutions, one of the big things that they had been talks for at least a year, it was getting a metal printer. And we kept talking about it, and things had kind of moved in a couple different directions. It wasn't happening, So that was one of the things that I really wanted to get into. I saw, how it was coming and how it's evolved. And when I came here, I just kind of mentioned, hey, we've been looking at metal printing. And he didn't say anything, but I kind of saw the spark there. He was definitely interested. Okay. After about 6 months of just doing just removals, work around the lab, he came to me and was like, hey, how do you feel about metal printing? Say no more. I'm 100% in. So we just started the research fund and going through and picking who we wanted to go with. And that took about 8 months before we finally made a decision.
I mean, those things aren't cheap.
Yeah.
No, they're not. Especially when you have no idea what you're getting into.
Can you go through the part of researching? Like, what do you look at? What do you do? I mean, 8 months is a long time to pick the right one. So, like, what's that process like?
So we met with about every rep we could find, looking at the show, just kind of seeing products, sending a bunch of samples out. Negotiating price was a huge thing. Obviously we kind of wanted to plan for growth. At the time when we were doing this, they didn't have a ton of partials coming through there. Right. So we wanted something to cover that, but we obviously wanted something to grow because we couldn't put a lab in that was going to do strictly metal printing and not have the ability to grow. So finding the machine that would fit our price as well as keep up with our quantity that we're looking to put out, it was challenging. And after hearing what the rep says and then actually talking to, like the actual manufacturers and whatnot, they differ a lot of times.
Right. Yeah.
They can do it to you, you'll get 10 frames on this plate, and you talk to them, and you're good to get 6 on a good day. So it was a lot of that, bouncing back and forth and waiting on, just samples and whatnot. That took like a month from every manufacturer. So we think we were getting somewhere, we get samples back, they look good, we get in talks, and then we get a sample back from someone else, and this one looks good. We kind of bounced around. So it was a lot of research just on the printing side as well, just learning what we were going to get into.
This was back in 22, right?
Yes. So we actually pulled the trigger in early of 22, but we didn't get everything here and set up and running until the end of October of 22.
So how many players are in this game, do you think, that sell these sort of printers in our industry? Is there a lot?
It's a lot, but a lot of them, the Chinese market is really just booming. It's exploding because they see the benefit to it. So you see multiple, close to 10 supplier or manufacturers that we've gone through, and they're not necessarily different. They're all the same printer, just rebranded. So we started kind of running into that. And then the same thing about getting service. Whenever you buy something with not a U.S. based builder, it was hard to try to figure out the service. We got told a lot of times it would be weeks. Things get solved within 2 weeks, and we're like, well, that's a long time.
It's not going to work. Yeah.
No, that's not going to work. Kept it down for weeks. So there is, I would say, about 8 right now that are big names, well supported here, and it's ever growing. The people that we went through when we got our first 4 printers, we got 4 printers to start off. They were the first ones in the U.S. So we did kind of take a dive into something that nobody knew about. They were the first printers that the reseller had sold. They're German made and whatnot, so they had a backing in the UK, but they just hadn't had anything here. So it was a leap, but they worked with us really well and gave us a great deal, being that we were the first ones. So that's kind of what made our decision. Was they managed to beat the price of we were looking at exact metal, and they actually came in and were like, hey, they were neck and neck on their production wise. It was pretty, no brainer whenever they came back with a price that beat theirs by a good bit. So that was the deciding factor there.
So you may not know the answer to this, but is it liquid metal? And if so, how does that work?
So it's actually called powder bed fusion is what this process is. So it's a powder metal, and it actually, you sieve it each time, you clean it and whatnot, and it's a really tiny, like a 10 micron grain.
Mm-hmm.
One reservoir that feeds that metal, which is just powdered metal, and the other side is your build plate. It puts a layer, so we run a 40 micron layer. So it puts a 40 micron layer of metal across, the top of your build plate.
Right.
And it lasers that layer in, and then just repeats that process over and over. The build plate drops a little bit, puts another 40 micron layer over, lasers that, and then repeat.
That's fantastic. And how long does it take to do one?
Well, that really depends on the height of your build. We average about a 5-hour build on our small ones, and we've only been running the new one a little over a week now, but it averages about 9 hours.
Wow. So you can run them overnight and then come in and get ready to go in the morning.
Yep, that's the plan. That's what we normally do. We run one run on each printer during the day, and then right before we leave, we cycle those and then run the other at night.
Can you hook into it? Like if you're at home and something happens, can you dial into it on your phone and fix it?
You can, but a lot of the things that you're going to run into it's going to be a physical issue. So the little supports that are printed sometimes kind of fall off or break or something like that, and that can actually jam like the arm that puts the powder on there, the coater arm. That seems to be like the most common is what we have. It just sees resistance, so a little piece of a support will fall in there. That's something you have to physically get in there and do. Most of the things you can do remotely are going to be like settings, changes.
Cool.
You can do a few things, but most of the time, no, you're just kind of stuck with it.
Yeah, most of the time you either have to go in or wait until the morning.
Exactly.
Yeah.
So does it depend on how many frames you're printing, or is it based upon on how high off the build plate it is for length of time?
It's a combination. So generally speaking, more frames your build is going to be higher regardless of what you're doing.
Okay.
But just like resin printing, it's the amount of layers you're throwing down. Mm-hmm. So if it's 40 micron, you've got that many layers, that little arm has to circulate around the machine and put that layer over and over. The laser's actually faster than the arm. So it's based on layering. So it's definitely the height of your build.
So what do you just dump a bunch of powder in the back of the machine and it just kind of dispenses it out?
Yep. It's like 2 cylinders is how it works. You have one cylinder that's your feed cylinder that holds all your powder, and you have your other cylinder, which is your actual build plate. So its build plate drops as the layers go on, and your reservoir goes up and then feeds that extra little 40 micron layer each time. So it's just got a reservoir. You just dump your powder in and let it go.
Interesting. Where do you get a box of powdered metal from? Is that from a distributor?
Yep. So we actually use Schaeffner metal. It's a big metal over in Europe. Really flexible. We've had good results with it and whatnot. Amazing shine and whatnot on there. So we've been running theirs. There are other metals. Bago actually has recently come out. They've got powdered metal. Denturum is another big name that's out there. There's quite a few metal powders out there.
And like the patients, is it like allergy tested and all of that? I mean,
it's got to go through all the same testing like your normal metal that you would be casting with. So It's most of the time it's exactly the same metal. So it's just granulated and set up like an ingot form. So it's the same stuff. Still has to be, health code. You still get your metal stickers where it was certified. So there's just as much research that goes into the powdered metal as it is anything else.
It's crazy.
Do they come out of the printer hot?
Not as hot as you think.
Yeah.
Warm. I would say warm.
Yeah.
So after you print your frames, they do have to go in an oven, like in a annealing cycle. So you run it up to about 1,000 degrees Celsius. They come out pretty hot.
And so what does that do? Like meld everything together?
No, it's completely solid when they come out of the printer. That's actually to reduce the stresses. So when it prints, it's full of supports, just like you'd see on a resin printer. You've got a bunch of supports that pop up and hold your frames in place.
Mm-hmm.
There's so much force or so much stress on those because it was lasered. So it was rapidly hot and then basically rapidly cooled. So it actually holds a lot of stresses. If you were to cut those supports off, they would try to spring in the shape that they have those stresses.
That makes sense.
Yeah. So yeah, you're not taking it to like a liquid state. You're just taking it to, like I said, ours particular is 1,000 degrees. You take it to 1,000 degrees, it releases all those stresses. It's only in the oven for 15 minutes, so it's really not that long. Ramps to 1,000, sits there for 15 minutes, and we pull it straight out of the oven and set it on a cooling rack. So it's just a fast stress relief.
Huh. I bet you it's glowing when you take that thing out.
It is molten. It is so hot. We have a big hood above it, so it catches most of the heat. But pulling that thing out of there, we have like a little tray that we pull it onto and move called a charge box. It's inside our oven. You have to run argon to keep the porosity and the oxidation off the metal.
Oh, yeah.
So it's got a little box in those you have to pull out, and it is very hot.
You can't cool that fast. Us ceramists, we like to grab things out of the oven, not right out of the oven, of course, and then put them between our hands and blow in them and try to cool them down. That's not happening.
Nope, it is far too hot. Like I said, they come out, it's 1,000, and it is a glowing box. It melts everything around it. We use welding gloves, and they instantly start smoking, and it's fun. It's a lot of fun.
That's that's over 2,000 degrees Fahrenheit. Well over that, isn't it? 1,000 Celsius?
That's a good question. I think
I should look at my conversion chart.
I think 1,000 is 1,800, somewhere in there.
Yeah. Okay.
It's hot.
Yeah.
I'll just say that. It's hot.
It's hot.
What happens if you didn't anneal it?
Well, that would relieve those stresses. So as soon as you break off the supports, the frames would actually bend. So they do have stresses on them in different directions, depending on the curvature of the frame. So imagine like a cup style. It's easier to close, like a C, I guess. C would want to close the points to make an O. That's what they naturally want to do. So when you cut their supports off, all those frames are going to want to kind of warp and bend. So
interesting. Okay. So after the anneal process, what do you cut off the supports? How the hell do you cut off metal supports?
I made a rather sketchy saw. So
a sketchy saw.
Okay. That sounds a little scary.
It's very Florida.
Oh yeah. You might be a redneck.
It's something. I mounted a bandsaw on like a plate, and I have a slide. So you mount the plate that we pull out, the build plate after it's cooled down. It's got little screws in the bottom where you can mount it. So it mounts to this little sliding apparatus I made, and you kick the saw and you slide it through it. So it's kind of like a desk drawer with a saw blade on it.
Huh. Sounds cool. And it works, I'm sure, right? You don't have to slice a finger off while you're at it.
I put a handle. It's still sketchy. It definitely works. I wouldn't let the novice go in there and start trying at it, but the guys here are pretty good.
Yeah, understood.
So that cuts all of them off of the build plate, but you still have to sit there and cut each individual support off of each individual frame, right?
Of course you do. That is rather time consuming because they are how we support them to get more frames. And we can get our smaller printers on a 110 millimeter build plate, and we average 7 frames on that. So we're doing a pretty clustered bunch of frames in there. So it does take a lot of support. And they actually just use like a pair of wire snippers and just slowly go through there and cut all their supports off of there. Once you get them separated, they cut off the frames pretty easy. It's not too bad, but the separation of the cluster is kind of the complicated part there.
So I didn't realize just like a wire snipper will cut those things.
So the supports are made, whenever they go to the frame, they taper to a very small point. So the support is relatively thick, but where they actually attach is small. So they've had that in mind. That makes it a lot easier. So it isn't just a hard support on that frame and you'd be bending them and trying to get them off. But the little supports are small enough that, just a pair of snippers, they go through and just flip them off.
And then what do you have to go buff off every single one of those points?
Yep. So that's what they consider finishing now. So they're not actually like shaping the frames or getting them to fit or doing any of that anymore. It's grown to basically support removal. And then you throw them. We have it's called a D-Light. It's an automatic polishing unit. So you clip 12 frames in that thing and it spins around and it does the majority of your, I say, quote unquote, finishing and polishing.
Mm-hmm.
Oh, that's awesome. Because that's a horrible job.
I'm telling you, I wish that was around about 15 years ago.
Yeah, no doubt.
So they throw them in there and then they have a much easier job of doing, they still hand polish every one of them. They still go over it with a rubber wheel and do just like the old style so that they look and fit and feel just like a standard frame. But it's about 1,000 times easier.
Are you guys doing frames for other laboratories, or are they mostly doctors?
So we're part, obviously GPS is the mothership there. We're the ones doing all of theirs, so they work with the doctors.
Mm-hmm.
But us here, we call it GPS RPD. We only work at labs. It is amazing.
Yeah, I was thinking that. Yeah, for sure.
Yeah, it sorts out a lot of those problem cases that you get in, or the just trash scans and whatnot that you can't do anything. At least a little barrier between us and them.
Do they design their own frames and send them to you designed, or do you have a myriad of things where you do some designs and?
Yep, exactly. Some people like their design. Some people just send us just an STL. They'll do all the hard work for us and send it in for the same price. We design it here. If most, I would say the majority kind of just drop them and say, "Hey, make a frame. Give us brief instructions of whatever it is." But we do the majority of the designing.
Can you do everything you could with a traditional method? I mean, rest seats, obviously, but all those frame nuances are all able to be done digitally?
Yep, they're able to be done, and they're able to be done much more precisely. So there's a lot of attachment housings and whatnot that before, when casting, they were a nightmare, and the doctors would normally end up just saying, I'll just pick it up in acrylic in the mouth and make it easier.
Mm-hmm.
Now we can print all of those to such an accuracy that it's making our job too easy. It's great. I love it.
That's cool. Do you print a model every time?
We do. We print. We don't have a model room here. I love to say it. We are completely digital here in the RPD lab, so that everybody gets a frame and a printed model on every case.
Wow.
What do you print the models on?
We just have resin printers. So we Haygears, the brand Haygears has a awesome automated model printer. So that thing runs all day, just pumping out models.
Yeah,
I've got the Haygears too. They're badass. They really
I
are.
love them. We at the main lab they've got some carbons that are they're pretty quick, but I feel like that Haygears for models is it's untouchable. Automated, you don't have to be there. It cuts it off the plate, dumps it in a can, and you come back later to a bucket of finished models.
Yeah, and they just keep going and going and going and going. You can nest them all night long. I mean I would agree. They're great.
I think it's great. We've got the reservoir for the resin, so even if you forget, it's got 4 jugs down there, so it just keeps, when one goes empty, it pulls in the next one.
Wow.
You can hook up 4 jugs of resin?
It's actually a completely separate piece of equipment, and it's got a little pump in there, and it's got the 4 reservoirs, and each reservoir, and you just put a jug of resin in there, and it's got a scale, and it'll tell you when it's getting low, and it's as easy as it gets. When one runs out, it shifts to the next one automatically.
Yeah.
Wow.
Yeah.
Printers have come a long ways.
So true.
Well, I want to go back to the electro polishing. What exactly is that? I mean, you said you stick 6 frames in there and it tumbles it around like a rock polisher?
So we used to use a tumbler polisher back in the casting days. It was made by mass finishing. They came out with a great quality finish on them, but when they tumble around all by themselves, they can kind of interlock those clasps and whatnot, and they would come out all bent and warped and whatnot, and it was frustrating. Mm-hmm. So this does, it actually has like a little apparatus that has clamps on each one that you clamp individual frames on every arm. So it can hold 12 frames at a time.
Kind of like a roach clip.
Basically. And it spins around it. It's got a media in there that does have kind of like the electro polishers that you guys would think of, like the acid polishers and whatnot.
Yeah.
It has little balls of acid inside the media. So as it starts, it adds moisture and activates those little acid balls because it does use an electro polishing, it does running current through there and whatnot. So that does the stripping of the frame and the more of the finished side. And then it actually dries itself. So it pumps air in there, dries the media, and polishes on the second stage.
Holy
That's
moly.
Fantastic.
They are really nice. And we've got ours dialed in, so we run it. It does 12 frames in less than 30 minutes.
That's got to save you guys so much labor. It's not even funny.
There's only 5 of us that work here, so we're pumping out 60 frames a day with 5 people.
Wow.
That includes designers?
That's it.
Wow.
You can really produce with a metal printer. You got to pay a lot for it, but it pays itself off pretty quick.
Sure. So after the electric polishing, how much time do you have human hands on it finishing it?
They like to keep it about 3 minutes. So if they can get one polished out and run it in 3 minutes. Obviously, the support removal is a couple minutes, so we've got less than 10 minutes on hand for everything, QC, everything on each frame.
That is so cool.
Yep, and as they're doing a batch, they're doing a bunch at one time, so they do one process, so it's actually a little quicker than that. If they're doing individuals, you got to slow down, do each one for the finish it out and whatnot. But it's pretty efficient.
So do they ever, this is going to be a weird question, but do they ever go out of calibration where like you're like all of a sudden the frames aren't fitting and you have to go back and look at all the specs?
Uh, we we in the last year we've seen a little bit of everything with these. So we being like I said, they were the first ones in the U.S. They were the first ones dedicated to dental as well. So there was a lot of learning curve in the first, especially the first 3 months. The first 3 months, we couldn't figure anything out. We did a ton of manual labor. So the dialing in is mostly nesting. The printers stay pretty solid. I mean, they just sit in the room all day. As long as you're not bumping them or doing anything on them, they really don't go out of spec. You know, everything stays pretty dialed in and calibrated and whatnot. But the nesting was our biggest hurdle to kind of get through. The warpage and whatnot that's caused by that laser is huge. So we had no idea that they would warp or do the things that we saw. So anything we had with like a flat plate or anything like that was just warped all over and not fitting, and we couldn't figure it out. And I probably laser welded for 5 hours a day.
Oh God, yeah.
It was a lot of fun. It was so much fun. And we found a nesting company called Octon, and they completely spun it around. They were the magic ticket we needed. And it actually automates everything. So you just kind of dump your frames in there, you check and make sure that everything looks as you're looking for, and you tell it to nest, and it has AI and nests for you. The most, compiled way that it can get it in there, and you get the most frames per batch.
Wow. So go back to the warpings. How is incomplete nesting, I guess? How does that cause warping? What did you say?
So what it is it's the lack of support. So and the style of the support. So the shape of the supports, as well as how many supports and where they support, all of that is crucial. Initially, we were using a support that was basically, it looked like 1,000 toothpicks. So they were singular, like just little pillars all over, but they weren't interconnected. And that was allowing warpage on smaller parts. They weren't really used to that on their other printers because they were doing more like larger manufacturing. With this, every part is unique. Every part is different. And the software just didn't know. It had no idea. It would print a frame, and some of them would fit, certain shapes wouldn't, certain orientations. I mean, you would have the same frame and you would turn it 90 degrees and it would fit fine that time. So it was a lot of that, learning about nesting. Our new supports with Octon actually has all interconnected supports. So it has miniature pillars that are all connected. And that allowed enough strength so that nothing twisted or warped or did anything like that. So that was the key.
So they already worked all that out for you, and basically it reads it, and the AI just goes ahead and takes care of it.
Yeah, it was definitely a learning. So it learns as you go. So our first few weeks with it was a lot of confusion, just trying to figure out like, what are we doing? What are we looking for here? Because again, I had no idea what I was doing. I know how to cast. I'm winging it. So we got that figured out pretty easily in about 2 weeks of using them, of what supports and how to support and what orientations work. And sometimes you got to throw a little connecting bar on a clasp that, is just being a nightmare. You got a long roach arm or something, and it's just too long for that thing not to warp, even with support. So you would kind of connect it back to the major connector and whatnot. Little stuff like that was just the learning curve, I would call it.
Wow.
I'm assuming that with a metal printer and the build plate going down, it doesn't fail like a resin printer that goes up. You know, when those are printing and you have a failure, it's kind of obvious, like mid-print. You probably don't see it until well after the process.
Nope, you don't see anything. As it's printing, it throws that extra layer of metal on, so every time it goes down, it just looks like a fresh plate. It looks perfect every pass until you pull it out and you see all those supports that fell off, or your machine screams at you because it's bound up because the support broke and is now, holding up your arm from being able to rotate and put powder on. You definitely get the surprise every time. Most of the time, not a good surprise.
Yeah. And you mentioned an arm. What is it, like a windshield wiper pushing out a fresh layer?
Yep. It's funny you say it. They actually call it the wiper blade. That's hilarious. It looks exactly like a wiper blade. It's got a little silicone blade that, looks like windshield wiper. And you replace that as it gets torn up. But yeah, it just rotates 360 degrees. It basically, while it's printing, it's running 360 all the time. It's just constantly going because the arm is slower than the laser. So yeah, that arm keeps rotating. Your reservoir pops up 40 microns, lets that powder spread, and your build plate goes down, and that arm just keeps rotating around.
So do you guys only have one option of the metal? Like, is it only chrome cobalt? I don't even know if there's any other options out there, but is it just that one metal?
That's all we offer here. Chrome cobalt is mildly reactive, but the titanium that you can also print, all of our printers are capable of printing titanium, but it is very reactive. So any sparks, anything like that, it gets pretty dangerous. And our landlord asked if we didn't blow the entire complex up. So he told us we should probably steer clear of that.
Why is that?
I asked. I told him he's got insurance. He would be fine.
You might end up in a better place.
Oh yeah, brand new building. It sounds like to me, but
why does it spark?
So it's granulated. So it's almost like a metal dust. And it's almost like, I don't know if you've seen like a grain silo or something. Those explode as well. Anything granulated and that small of a piece is flammable. So it will actually combust.
Damn.
Yep. So
that's crazy.
Yeah, chrome cobalt isn't bad. It's pretty mild, less reaction, and it's also less your hands and whatnot aren't going to break out or anything like that. It's a pretty easy to use metal, and it's the most common, also the cheapest. So
yeah,
the printers are able to print titanium. Does that mean you can do bars and abutments?
We absolutely can.
I was thinking abutments. I wasn't thinking bars. Wow.
We do a decent amount of copings and whatnot right now with what we've got. We don't do enough titanium to print. They mill all their titanium, so at the amount that we are at, we said it's just not. When we're looking at one, it's not as much work as this. So we just kind of stuck with this. Again, not knowing the printers either. When we first started, we were like, are we really going to go titanium? Do we really need this? So we bought titanium capable printers. But after a short period of time and seeing what we've got going on, we said, just the load isn't there and how much we would have to change. Because you do have to do a lot using multiple metals. So if you're using multiple metals, you need a machine dedicated to that. And that comes along with everything else. Your sieves that filter your metal after you're done using it, because you just reuse your metal. So everything that's still in a powdered form, you run through a sieve, it filters out all the chunks or bubbles or any splatter that laser caused, and you just have same metal right back to it. So there's very less than 1% loss. So
wow.
Yeah.
Wow.
So the sieve, I believe, was like $10,000. It was ridiculous. So we're like, well.
Was it just like a coffee filter?
Basically, it's an ultrasonic coffee shaker. It just shakes it out, and then it's a screen that shakes. I mean, it's the easiest thing ever.
For $10,000.
Yeah, I'm in the wrong business.
Yeah.
Our vacuum, just the vacuum that's safe, that goes through and pulls all that metal powder so it's not particularized in the air and whatnot. It's also blast safe, and I believe that was $14,000. So
wow. Damn.
It's very expensive when you start to get into it. You see the printer price, but you don't know that there's a lot of other things that go in there. You've got ovens, you've got your saw that you have to try to figure out because nobody makes a saw for this. You can buy a very big, expensive industrial saw, but at the same time, it's cutting off little tiny parts and it's pretty rough. So there's a lot that goes into jumping into printing that we didn't really know until we kind of dove in. We're like, oh.
I don't think anybody does. But the vacuum, so what's the maintenance on these? You got to vacuum it out every time?
So you basically, when you open the door, there's like a residue around the outside, basically stuff that you don't want to breathe. When you first open it, a little bit of that metal falls out. You're basically cleaning it with a vacuum to the point to get anything that you can't brush back into that catch reservoir.
Okay, yeah.
Obviously, you want to catch as much metal as you can. Any metal that you catch is safe, so that's free. So we try to save and catch as much as possible. And then the vacuum does have a bag, and it catches all of your metal. So that metal we just use for toys and trinkets and stormtrooper heads and everything else that we do. So I
saw that online. Yeah.
Oh, so wait, you can use the metal to print like faces and jewelry or anything like that? You can reuse it?
If you can make an STL for it, this thing will print it.
Wow.
It's pretty fun. We've printed some interesting stuff. We'll say that.
Out of the vacuum metal.
Hey, it's free powder. We said, hey, if it's free, I mean, we got to do something with it. We can't,
I hear you.
Can't put it in someone's mouth, so I mean, we have to make something completely useful to us.
Oh, cool.
Stormtrooper heads, very, very useful.
But what other maintenance is involved? It's not like you're replacing burrs or anything like that.
So they basically come in every 6 months to a year, whichever you kind of sign up for. You sign up for a maintenance plan.
Yeah.
And they come in and do all the technical things that I don't know what I'm doing in there and poking things and wiggling wires and whatever it is that they do. I honestly have no idea.
Yeah. Let them do their thing.
There is filters that kind of catch. So whenever you laser, it puts off a soot. So you're heating that metal and whatnot. It's taking it to a liquid state, which is releasing gases. So there is a filter that catches all that in the back that you replace like every other month or so. It kind of tells you. You can see that it's not working like it was, or it'll pop up an error and say, "Hey, time to clean." But other than that, I mean, there's not a ton of like maintenance like that. They just kind of run until you hope nothing breaks. And
yeah, what happens if it does break? It's $10,000.
Well, we just left our warranty period, so we don't know yet.
Ooh.
we
Nice.
we called the guys in Germany, and they tell us how much we have to pay them, I guess.
Yep.
So far, like I said, everything's been under warranty that we've had anything happen. So far, we've had a pretty good run.
So how do you know when you need another printer? I mean, obviously it's because you get too busy, but I mean, if you're running it 24 hours, is there any plans to get another one? And if so, like, how do you know when you just can't keep up with the volume anymore? And or do you guys keep selling to labs? Like, what is your business plan?
Well, what we did, so like I said, we just did get a new printer last week. So once we were to the point where we were running all four, basically all the time, we
Yep.
realized we didn't have a backup plan. So when something breaks, we were in a real pickle.
Mm-hmm.
So we opted to just go ahead and get a new, bigger machine this time. So
Wow.
that takes up. So we got our new one will run about 24 frames instead of the others running 7 apiece. So it's a longer build time, but it is faster because we're getting 4 times as many on. It's definitely an improvement. So we like this guy.
24 frames at once?
Yes, we got a 3D Systems Flex 200. So it's got a 140 millimeter build plate. So it's square as well. So instead of being round, you've got those corners to work with. And yep, I just loaded. This morning's nesting took 22. So depending on how many uppers and lowers and size of frames and whatnot, it's pretty nice.
You went with a different company of the printer that you already have, or you went with the same company with a better, bigger printer?
So our first ones were made by 2-1 Labs. They're like I would call it a great entry level machine. But now
Yep.
that we're really ramping up, we needed something a little bigger.
You went for the big dog.
We went for the big. They only offer the small printers. They're in works of building a bigger printer and whatnot, but it wasn't timed out for what we needed. So we kind of had to take a dive into this big guy here. So I flew out, saw the facility. They do a ton of fun stuff out there. I mean, they're doing spines and stuff. They're doing really intricate, real like heavy into medical. The FDA has an office there. They just hang out there all the time. That's
Wow.
what they're doing. So yeah, I got to play around there a couple times, and that was the deciding factor. Seeing this huge place. They've got one in North Carolina and they have one in Colorado. So it's we can kind of get people here and whatnot. So we like that aspect of it, and
Nice.
it's so far it's been great.
And they're not just dental.
No, they aren't just dental. They are heavy into medical. They do a lot of SLS printing as well, which is the plastics and stuff. So it's kind of like similar to resin, but it's like a powdered plastic. So they use a laser as well. So that's a really cool thing that they're doing out there. They've got a lot of fun toys out there.
The labs that send you work, are they all over the country or are they mostly in Florida?
We have labs from Florida to Washington State. So we run the gamut of everywhere in the U.S. Obviously, being digital now, it's so great. You can send a case over, you can do all your reviews. You're not back and forth on a stone model, and then 2-day shipping, it's right back to you. So it's great to be able to reach out everywhere.
So how long is the process? If a lab sends you a model, or I imagine just an STL of a scan, when can they expect a frame back?
5 days. We keep it for 5 days here. We always try to kind of kick them out. We like to run it at 4 days, honestly, and keep that spare day for just in case. But 5 days from the day that we receive it to the time it's leaving here is 5 working days.
And it's completely finished, polished to perfection.
Ready to roll, perfect.
I've seen printed frameworks in the past, and they didn't look great, and they didn't look like traditional frameworks. You're telling me these things look exactly the same?
You can't tell the difference. So a few years ago, I would say 4 or 5 years ago, when I first kind of got into looking into these, you could flip them over and you'd see all the build layers and everything was kind of grainy. It's nothing like that. The orientation that we print them, we put any of our supports or any of our stuff that's going to be, kind of cosmetically imperfect on the side that we're going to polish. And being that we hand polish every frame still, it is exactly the same. There's some that, you kind of see that they just run through that polish unit. And if you leave it at that, it doesn't look like that casted frame that everybody's looking for. So we went ahead and just took the step. We still hand polish just like the old style on the same lathes. I've still got the same lathe I've had since I started in the industry. So
That you got for free from that other lab?
that is exactly right. That's exactly
hilarious.
Right. It is amazing how much stuff they threw away.
Man.
Right place at the right time.
I'm telling you. I got that laser welder. So it was a Laser Star laser welder. I'm a great welder. I ran it for a few years, and I was working at the other lab, and their welder broke. And I was like, I have a laser welder at home, and everybody looks at me like, what are you talking about?
Nerd.
I have a laser welder in my shop. What do you mean? I weld jewelry for the local jewelry shop. And he says, well, I have this delivery car. You want this I'll trade you a delivery car for your welder. I said, well, absolutely. I need a 4-door car. I was driving a truck at the time, so I traded that laser welder that they threw away for a 2-year-old Corolla. I mean, it was
Wow.
great. I was like, yeah, absolutely. Car for free welder. That sounds like a deal.
It's a trade up, if you ask me.
I'm telling you, it's amazing how much stuff they threw away that I just took home and resold or used or gave away. It was the perks of working at corporate.
Yeah, for sure.
So has anything about doing the frames changed, like the designs or anything that's been updated throughout the years since you started?
I wouldn't say design because a lot of those doctors are stuck in their ways and they want exactly what they've always got.
Yeah.
So we tried to avoid some stuff when we were first, learning and whatnot. We were having some, fit issues and whatnot based on that nesting. So we kind of modified stuff and tried to steer clear of certain things. And now that we've got everything dialed in, it is exactly as it always was.
Wow.
Nothing's changed. Doctors actually question it. Are you sure you didn't cast this? We don't cast. So absolutely the same as always.
Are there any scans you get that you just can't do it on?
No, I mean, obviously if it's just a terrible scam, but that's just
Sure.
anything that you can design on. But no, we haven't found much of anything that we can't nest. Obviously, every once in a while you'll have something that comes in that's real wonky or something weird, and you may have to do it 2 times just to get it dialed in perfect. But very rarely do we see that anymore.
What is your success rate of it printing and then just like dropping on that model?
Nowadays, about 95%. They are dialed in now. We got it figured out.
Spectacular. Wow.
New printers, took very little to get dialed in. I mean, that was one test print. One test plate. It was there, and same thing. We're a week in, and it's fitting perfect. So we definitely figured something out in the first year.
Wow.
Are you blocking out on models?
Digitally, we don't do any actual physical blockout.
Sure, yeah. This is what I meant.
Yep, exactly. So we still block out on the models just like you normally would, but I design now just like I did when I was doing print to cast. So it's exactly the same process, same blockout rates. We can actually make everything a lot thinner and more flexible now is the biggest thing. Obviously, when you're casting, that metal has to have a certain size channel for it to move through when it's liquid. Yep. So if you made your plates too thin and whatnot, it would short cast. So you saw a lot of stuff that was like 1.5 mil thick. You've got a lot of metal in your mouth, and patients hate that. We can keep these plates under 1 millimeter and still keep that strength, and it is ultra light, and people seem to love that.
Interesting. What about clasp? I mean, those don't have any issues with fit or finishing or anything?
So the biggest thing with clasp for years is they were not flexible. For whatever reason, the print process they just weren't there. And so when we started printing, that was one of our biggest things in the research side of things. Like, hey, we have to have flexible clasps. We can't have these stiff clasps that look great that don't work, because that's counterintuitive to what we're trying to do.
Got to go over that height of contour.
Exactly. So once we kind of dialed that in with the metal company, that's why we went with the company we went with. We tried a few metals, and that Scheffner metal with our annealing process, we joke. When I take them to the shows, I have a bunch of them out there, and people were kind of timid about it. I'm like, no, bend on it. Bend it back and forth, up and down. You can bend those things like I've never seen a clasp bend in my life. They're the most flexible. We had a count on one of our favorites, and it was into the hundreds of how many times people bent it back and forth and made it springy and played with it. It has come a long ways.
Wow.
So we're talking about it being easier for chairside adjustments.
Absolutely. You can wrench them around and bend them back in. You're not screaming because you got a finished partial that you just broke the clasp on. You got to restart. That is a thing of the past.
And I imagine, dumb question, but got to be stated, you finish it just like every other metal partial. I mean, you still put traditional acrylic on it.
Yep, exactly. We did a handful of resin printed saddles, and they were good. The acrylic just isn't there. It's not high impact yet. So we kind of steered away from that just until they kind of get that dialed in. I know Stratus is kind of working on stuff like that, and we looked into a few of those. But even that was all in one design. You could design everything from start to finish. So you would basically be putting your Legos together. You'd pop that frame out. The teeth and everything that you designed would just lock right in, and you would just lute it just like you would do a normal digital denture.
What about if someone needs to add a tooth to one of these printed clasps and you need to add some metal support?
So the metal is just like it was, so we can weld to that or do anything like that. And now it's much easier because most of the time, instead of just welding a little wire loop that always tends to break off or the acrylic spin, we actually just designed a little section for that and be able to print it like perfectly. So it just locks right in. You put a nice strong weld around there, and you have a partial that doesn't look like it was repaired. It looks like it was always like that. So that's another huge plus the doctors love.
Are you talking about printing just an additional piece or reprinting the whole thing?
Nope, just that little section. So if you lose, a tooth or two, we actually print a section that is metal with a finish line and the mesh and everything, so that whenever you get it back from me, they ask, "Did you reprint this, or what's going on here? I wanted the same frame," and it's it. That's just that little section, and it's so much easier, so much stronger, so much more comfortable.
So you're just laser welding that on in place?
Yep. We just throw a little laser weld around there, but how you design it, it's snug around that entire section. So you're putting it on there, you're not filling a gap or anything that's potentially a weak spot. So we barely use any fill on those because we design it that it locks in so nice.
So you pretty much custom make it.
Exactly.
Do you go back to the original file?
No, we just scan the frame in. So we'll just frame on model, spray it so it doesn't reflect, and then scan that in, and then we design right off of that. So you're actually working with, your frame, your exact setup there, and it's just as easy as making it's the same design process as making a new frame, but it's only a small section, so it only takes a minute or two.
Sure.
That's what we used to do back in the old days when we had to add a tooth to a bridge, like a PFM bridge. We would just cast that one ponic area and weld it back into place.
Yep.
Makes sense to me.
It seems like a huge pain in the ass. You'd have to strip off all the porcelain and redo it.
Back then, yeah.
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 You mentioned you're printing chrome cobalt copings.
So yeah, we do anything that's 3 unit or less is what we're doing right now. The other plan for the addition of the new printer is to dedicate one of our smaller printers to doing fixed work. So that is actually, as of Monday, we are testing with those. Just trying to, again, that annealing process is absolutely key. So when you do that, just like when you're running a porcelain oven or anything else, you have to do it in steps, you have to do it in stages, you have to hold for certain amounts of time. And what that's doing is actually pulling the flexibility out of the metal. So obviously you don't want anything to warp or move, so you lay that porcelain on there, you throw it in the oven, you come out, it's all cracked because the bridge warped.
Yep.
We're annealing it so that it all just lays and stays exactly how it's supposed to. So it's a lot longer of an annealing process. They have instructions for it. It's a very common thing to do with this metal. We just haven't done it yet, so we haven't kind of released it to everybody. But that is what we're doing as we speak.
Are you guys still doing a fair amount of PFMs?
Surprisingly, yes, which is weird. It's not. They come in waves. You'll get like 10 in a week, and you're like, what's going on? I just got all these, and then in 2 weeks you'll have 1 or 2 a day. You're like, what is going on? It's people stuck in their ways.
Mm-hmm.
But chrome cobalt, don't you need special porcelain for that?
They do non-precious primarily over there for their copings of what they're doing, so they're already kind of versed in that.
I get you. Yeah.
I don't play with porcelain, so I don't know.
No, I hear you. No, I don't either.
Elvis doesn't either. There was a meme about that, by the way. That was funny.
So how do other labs find you if they're looking to outsource some frames?
Well, that's super easy. We've got an online portal, so you just you hop on there, you fill out the info. There isn't like an account service. It actually is on the back end, so it makes it even easier. You just fill out a form one time, and autofill for you every other time. That's gpsrpd.com. You just hop on there and drop everything in, and it comes straight to me.
Sweet. And then you just upload it, create a new account, and start doing business. And you teach them how to send the files, or you tell them how to send the files and everything to you, and then you just make the frame.
It is super easy. The portal style is it kind of looks like a Shopify thing. It's just for ease. You hop on there, and it's got like pricing. You don't actually pay. It's just like a normal billing cycle. We bill on the back end.
Sure.
Yeah, you just hop on. It's got a spot for you to drop your files. You fill out all the info, and then done. It is much easier. We were doing like an email thing at the beginning until our portal was set up, and that just kind of got confusing. So dialed it in. We've got our office worker up front. She brings everything in, sets everything up, and it's super easy now.
Wow.
And you even, I just noticed, I was looking on your website, you actually add teeth in acrylic if you want.
Yep, we processed it full. So we have the full service lab next door.
That's pretty unique to this service, I think.
Yep, everybody that wants those immediates or straight to finish, like this time of year when everybody wants their partial done in a day and a half. And
oh yeah.
Yep.
No.
I need teeth for Christmas. Why did you tell me in November?
Yeah, I'm going out of town, and
it's an out of country wedding every time. Yes,
of course.
Yep. So no, it's definitely an easy process now with us.
Sweet.
That's great. And if my doctor just says upper, you'll handle everything. And if they also send me a script with 3 pages of instructions on clasps, you'll all do that too.
Oh, we see both of those every day.
I bet.
We actually just teamed up with Full Contour as well. So you can use Full Contour and just drop it straight through. So the 3Shape Connect, you go through them, you select that you want us as a manufacturer. So they'll design if you'd like, and then send us the manufacturing file, and we pump it out and send it back to you. So that's another option.
There you go. That's super easy. Scan it into 3Shape, use 3Shape Connect, design service, and then go right to,
Yep, super easy. So we're in works of a couple of people that are interested in that as well. It seemed to be kind of a demand. So we said, well, absolutely, we can print anything. So if someone's taking the ease of designing off of us, and we'll go for that too. So
how much more work can you handle?
Well, now we've got this new printer, so we've almost doubled our production capabilities, but we're going to dumb it down just because we're going to take one of the small printers away and use it as our fixed work. So we're looking at about 40 more a day that we can take on after the first of the year.
So that's 100 a day.
Yep.
That's awesome.
We're looking to ramp it up. So we were full force. We got busy towards the end of the year, and we realized we had better step this up a little faster than we expected. So we went ahead and pulled the trigger and got that new machine installed.
Well, good for you guys. That's fantastic.
Yep, it's been good.
Yeah.
Yeah, what a great success story, man.
Yeah,
I mean, just talking to Andrew, and I remember that conversation, how it was so new and he was just thinking about it.
I remember.
And now here we are. And Josh, you're killing it, man. I love it.
I mean, from bait shop to metal printing, it's been a run.
I think you just named the episode.
You know it. That's actually true. I love it.
It was hilarious at how many people for the first year we were there that came in with their bait buckets and looked around as if they'd just seen a ghost. Like, well, do you guys still have minnows? No, guys. We can give you some dentures, but we do not have minnows anymore. We opened the attic and it was full of old hunting supplies. We're like, cool. We have a bunch of old arrows and bows and parts of guns and stuff up here where they used to repair, anybody's rifle and whatnot. I was like, well, this is kind of cool. We got bonus stuff. It was fun at the bait shop.
That's crazy. Well, Josh, thank you so much, man. Appreciate
Thank you.
I love that you're not the manufacturer of this, but you just kind of gave it to us in real use metal printing. I loved it. I learned a lot.
Same.
Yeah, not a problem, guys. I've done a lot of research and we've hit a lot of facilities, and people reach out to me and ask me all the time just metal printing questions, and I don't mind. I have no enemies in the dental world. I tell everybody all the same thing. When Bertram's got a question, Tim Bertram reaches out, I say, hey, I'll give him any answers I got, because the only enemy I think we have here is sending overseas. So that's my goal for everybody. If anybody takes anything from it, even if you don't send it to me, send it to the U.S. Pick one of us.
There you go.
We can do it, and we can do it better.
Yep.
Love it, Josh. Thank you so much, man. We
Thank you.
appreciate you.
Sure thing, guys. You guys have a good one.
You
Yep.
as well.
We'll talk to you soon.
All righty.
Bye.
Bye.
A huge thank you to Josh for coming on our podcast and talking about such a new and interesting process of making frames. I was really digging it, as you can tell. I think Elvis and I were both geeking out, but as this technology gets better, it will become more common, hopefully, in labs. And Josh, you'll definitely be at the forefront of the metal printing in our industry. It is pretty amazing that you can make a quality frame and only have to put about 5 minutes of actual hand labor into it. Frames have always been a hard thing for labs, super dirty, super hard. They're just a pain in the ass, and to keep it in-house, but this sounds like a really good and easier solution. So head over to gpsdigitalrpd.com for more information. Thank you, Josh.
All right, everybody. That's all we got for you this week. We'll talk to you next week.
And we'll see you soon.
Bye.
Yeah, baby.